Hey everyone, welcome back to the channel. Today I've got something absolutely fascinating and maybe a little unsettling for anyone who's been following the world of artificial intelligence. We all know that AI has been making huge strides, right? We've got chatbots that sound almost human, algorithms that can write entire novels, and even machines that can beat world champions at chess and Go. But here's the big question. Can we actually get machines to think like us? To handle any situation, any challenge, just like you or me? Turns out we might be hitting a huge roadblock, and no one expected it. Let me ask you this, what if all the scaling, the bigger models, the more data wasn't actually bringing us closer to human-level intelligence? I'm talking about AGI or artificial general intelligence. We've always assumed that with enough training, enough data, AI would eventually learn to generalize just like we do. But what if the way we're scaling things now isn't enough? What if we're missing something fundamental? So, let's break this down. There's a concept in AI called out-of-distribution tasks, or OOD. Now, what does that mean in plain English? Imagine you're training a model to recognize cats. You feed it thousands of cat pictures from every angle, every lighting, every breed. But then, one day, you show it a picture of a tiger. Suddenly, it doesn't know what to do, because it's never seen a tiger before. It's a totally new situation. That's what we mean by out-of-distribution. Situations that are different from anything the model has encountered. For humans, we can handle that shift. We understand that a tiger and a cat have similarities because we've got tons of experience with different animals. But for AI, not so much. Here's the twist. For a long time, the big idea was that if we just scaled up these AI models, made them bigger, gave them more data, they'd eventually get better at handling OOD tasks. But according to this new research, that might not be the case. These larger models aren't magically learning to generalize to unfamiliar tasks. This study found that, even with all this extra scaling, the models don't improve at handling these out-of-distribution situations. It's like giving a calculator more buttons, it can do more complex math. Sure, but it's still a calculator, and it still won't know what to do if you ask it to play the guitar. To put it another way, it's like a student who studies algebra until they're an absolute expert. Suddenly, they're thrown a chemistry problem. Just because they're great at algebra doesn't mean they'll understand chemistry without starting from scratch. And that's exactly what we're seeing with these big AI models. They get great at one thing, but take them out of their comfort zone, and it's like they're back at square one. But here's the million-dollar question. What if there's another way? What if, instead of just building bigger models, we need to rethink the way they learn? Imagine if AI could not only perform tasks but could actually reason, to really understand cause and effect, context, and even make leaps of logic. Some researchers believe that integrating different kinds of reasoning into AI models, like symbolic reasoning or even memory-based approaches, might help them generalize better. It's almost like we'd be teaching machines to think in a way that's closer to how we think. But will it work? Alright, so what does all of this mean for AGI? If scaling isn't enough, does that mean AGI, the idea of machines that can handle any task, think creatively, and even solve problems without training, is just a dream? Or are we on the brink of a breakthrough that could redefine AI forever? I'd love to hear what you guys think. Are we closer than ever? Or are we staring at a brick wall in AI development? Drop a comment below and let's get a conversation going. And hey, if you enjoyed this breakdown, don't forget to hit that like button, subscribe for more insights like this, and share this video with anyone you think would be interested. Thanks for watching and stay curious. I'll catch you in the next video.